VLSos here. This is a video lesson on functions. This is a brief reminder of the general concepts and vocabulary that we use with functions, intended for students that are starting pre-calculus. I'm going to write down an equation. Y is equal to 2x plus 1. This is in xy notation. X and y are simply standard choices for variables, but our variables could be represented by any letter. I can change this into function notation by replacing y with the name of a function and its argument parameters. So I can change this equation into function notation. F of x is equal to 2x plus 1. But putting an equation into function notation doesn't make it a function. For a mathematical equation to be a function, it has to have what we call one-to-one correspondence, which we'll talk about in a little bit. Function notation is wonderful to use because functions have names. The name of this function is f. We could use any letter to be the name or symbol, or we could use entire words to be the names of functions. The argument parameters are the parentheses, and what we put in the parentheses is the argument of the function. It is the variable that we're going to do the math on. This is the argument. And the mathematical process that works on the argument is the expression. There is many more vocabulary terms to distinguish between the argument or the input and the output, x and y. X and y are the typical choices for variables. X is typically what we assign to be the input. And y is typically what we assign to be the output. As if a function was a machine, we put a number into it, it does a mathematical process, and then produces the output. X can also be called the independent variable, or the input is the independent variable. And the variable for the output we call the dependent variable. To capture the idea that the output depends on the input. When we use tables to organize points for plotting on a graph or for arranging data, typically we choose values for x. We can choose anything we wish, which captures the idea that x is independent. And then we do the mathematical process or a mathematical process on those values to produce output. So the values that the g function uses or produces depends on what we put into the function. This function g must be different than what I've chosen f to be. That means that this table of values doesn't come from this function, and we can be sure of that because different names were used to show a function table and a function equation. More vocabulary for input and output. The set of all numbers that we can put into a function, we call that function's domain. And the set of all numbers that we get out of a function, we call its range. Functions can be graphed. A graph is a visual representation of the relation between the variables. The horizontal axis is typically x, vertical axis typically y. Functions can exhibit a variety of behavior and have a variety of attributes. This one curves all around. This function does not come from the table that was arranged here, nor is this curve a graph of this expression here. So it should have a unique name, and we'll call this h. I can highlight any point on h, and the coordinates of the point would have an x and y value. 5 is then in the domain. It's part of the input. It's an x value. The 1.7 depends on the input. It's an output. It's part of the range. 1.7 is a y value. More language that we use to describe different parts of the coordinates of the point is where and what. So I could think of and ask the question, where is this point? It's at 5, highlighting the domain value 5. I could ask, what is the value of the function at this point? 1.7. More language that we use for points, at and is. This point is at 5. The function at this point is 1.7. And lastly, the words argument and value are used typically to distinguish between x and y. If we put 5 as the argument to the h function, it produces the value 1.7. Functions must have one-to-one correspondence. If they don't have one-to-one correspondence, then the relation is not a function. One-to-one correspondence means for every value in the input, there must be only one value in the output. We can see on a graph if it is a graph of a function by the vertical line test. A very fast visual way to determine if a graph is a function. Vertical line test is imagining a vertical line anywhere on the graph. If there is no place at which a vertical line intersects more than one point, then the graph is a function. If there is any place that we put a vertical line on a graph and have that vertical line intersect more than one point, then the graph is not a function. Imagine if we put a vertical line at a location that's going to have an x value. That means that at that x value, if the line intersects in more than one place, then for that particular input, there's more than one value. If we had a t-table and we saw that we put 2 in and got a 6 out, and we put a different value for x in and got the same value out, that's okay. We can have the function have the same value at 2 different places. But if we put the same value x in this case 3, and got 2 distinct values out, like a 4 and a 6, then this breaks one-to-one correspondence, and g can no longer be a function, or g is not a function if this table of values is produced.